This video will help you work on evaluating expressions and changing things from logarithmic to exponential form. These are skills that build on each other. It's very important that you're comfortable going from one form to the other. So let's practice. I'm going to do one with you, and then I want you to try one on your own. So here I have the base. Remember I showed you this arrow. So you have your base here, 19, that's my exponent, and that's a number. So when I'm changing this to log form, I'm going to write log. Now what's my base? 19. And notice I write it small and down below just a little bit. So 19, this is the order that I'm going in. Log base 19 of 361 is 2. Alright, so that would be changing it from exponential form to log form. I want you to try that one. Never mind. I'm gonna do 3 with you, and then you hit pause and try these 3, and then the answers will pop up. So here, if we have it in log form, we want to change it to exponential form. We're like, okay, well, log base 12. If I read this correctly, I tell myself what the base is. Log base 12. There's my base. To the second power equals 144. And we can check and make sure this is a true statement. 12 squared is 144. Yeah. So double check and make sure. Does that make sense? Yes, it does. All right, find the value of v in each equation. And you're going to see, I want you to be able to do this even without the v. So if I just gave you log base 10 of 1000, I want you to be able to evaluate. And the question we're asking, 10 to what power gives me 1000? 10 times 10 times 10, so the power of 3. So I can replace this whole chunk right here, log base 10 of 1000, with 3. This is much simpler to work with. So this is considered evaluating, or finding the value. Okay? Alright, so I want you to try these 3 over here. Go ahead and hit pause right now, because I'm going to put the answers up in a second. Hit pause, try those 3. So here are your answers. Right? Log base 20 of 8000 equals 3. Base of 5. Log base 5 to the 6th power equals this. And here we have 15 to the v power equals that. 15 to what power gives me 252? Well, I can figure out that I just have to square it. Alright, let's try some more. So if we needed to evaluate 2, I'm asking myself, 2 to what power gives me 32? I know that 2 to the 5th power gives me 32. So I can take this whole statement and simplify it to 5. 5 is much easier to work with than that. So this right here is equivalent to 5. Log base 2 of 32 is the same thing as 5. I would rather work with 5. I think you probably would too. So when we see this, we need to recognize, oh, whoa, I can make this way simpler. Log base 2 of 32 really is 5. All right, how about this one? Now we're going from a bigger number to a smaller number. How are we going to get something smaller? Some of you might think, oh, well, negative. We need to consider, what do negative and exponents do for me? And what does a fraction and the exponent do for me? So if I want to go, okay, log base 25. 25 to what power gives me 5? Well, I know that this is 5 squared, but I need to just get to 5. I think this is a little too confusing for right this second. Let me switch the way I'm going to do this. All right, so 25 to the what power equals 5? Well, I know that 5 squared gives me 25, but to go backwards, I need to square root. So I know that the square root of 25 is equal to 5, yeah? But I want to write that as a fraction, as an exponent. So 25 to the 1/2 power, right? Our roots go in the denominator, equals 5. So the exponent that we're using is 1/2. So I could replace this whole thing with 1/2. Whew, I'd rather work with a half than log base 25 of 5. But these are equivalent expressions. All right. Go. Okay, so there's this one-to-one property. It's a really, really useful property that you're going to love because it's going to make your life easy. But it looks confusing at first, so we need to kind of figure out what it all means. This one-to-one property, if we say, okay, log base b of b to the x. Ooh, there's lots of b's. Okay, this is in log form. If I want to change this into exponential form, let's try it. We're just going to put question mark because we're not sure what it equals. We're just going to say, okay, log base b, my base is b to what power equals b to the x? B to what power equals b to the x? That's what we're asking ourselves, and some of you see it automatically. Same base. Well, what does the question mark, what does it have to equal? If these two sides of the equation are equal, then if they have the same base, they must have the same exponent as well. So the question mark equals x. So the exponent that we're looking for, this whole expression, equals x is our answer. Now notice our answer is right here. When we have a log with a base of b, and then of a base that's the same, our answer is just staring you right in the face, right there. Because logarithms and exponential functions are inverses of each other, it's almost, I don't want to say they undo each other, but they do sort of. So your answer ends up being right here. And it comes in really handy when I ask you a question like, I might say log base 3 of 9, but you know, oh wait, 9 is the same as 3 squared. So log base 3 of 3, the answer is staring you right in the face, saying what exponent do I raise 3 to get 3 squared? Oh, 2. So here when I see this log base 3 with the same base here and an exponent, my answer would just be that exponent. All right? We can go the other way and say, okay, base b, so now this is in log form, but this is in exponential form. I know there's little logs sitting here, but this really is an exponential form. Sorry. So my b is my base. So I want to write it in log form. Log, oh, sorry, let's try this again. I'm going to put my question mark out here because I want to figure out what does it equal. So I'm going to say log base b, right, this is my base, log base b, so I write it little and down, log base b of question mark equals that. Log base b of question mark equals this whole exponent, equals log base b of x. Notice what's the same and what's different. We have log base b of question mark equals log base b of x. What must the question mark equal? Aha, again, staring you right in the face. Same base. When I have a base of b with a log base b and these bases match, my answer is right there staring me in the face. So that equals x as well. So again, here I have a base of 9 with a log base 9. The answer staring me in the face right there. Now we could kind of go the long way and say log base 9 of question mark equals log base 9 of 2. So what must my question mark equal? 2. And we can do it the long way to make sure, but really when we have the same base, this is called the one-to-one property. When we have a base of 9 with a log base 9, this ends up being our exponent. All right, what do I got for you? All right, great. So you're going to be seeing, I know students always say, Ms. McSorley, make it sound so easy. It's not going to be that easy. You're going to give me stuff. It's going to be tricky. So where does it get more difficult? Well, I'm going to end up, we're going to get to solving. And you're going to have these complex looking things, and you need to figure out what they equal. So in this situation, base 5, log base 5, what happens here? What could I replace this whole chunk with? Good. If you said 7, I like that because the same base, we just talked about that one-to-one property. Here, these are the inverse operations, so really we just get 7 as our, so we evaluated this and replaced it with 7 because they are equal. And then here I have log base 3 of 9, so I could change that. I could say, okay, well, 3 to what power gives me 9? 3 to what power? Well, I know 3 squared gives me 9, but another way of looking at it is log base 3, and I can rewrite 9 as 3 squared. So now I have log base 3 of 3 to the second power. So this would evaluate and just be 2. So 2 different ways of looking at it, using the one-to-one property or just asking yourself what exponent can raise me from 3 to 9. 7 plus 2 equals 9. All right, so I'm going to give you these interesting things like this, and you're going to tell me, oh, that's just 9, that's 7, that's 2, add them up, you get 9. Okay? I want you to try this one. So go ahead and hit pause, try it, and we'll talk about it in a minute. Remember, we talked about this in class. How do I get from 6 to a fraction? Remember Kevin, good job. He told me there's something important that we need to put in that exponent. All right, so go ahead and hit pause right now, try it, and then hit play. So here, using the one-to-one property, we do get 3. And here, 6 to the negative 2 power is 1 over 36. Because negative 2, that negative in the exponent makes the 6 become the reciprocal, and 1/6, but then 1/6 squared. So 3 plus negative 2 equals 1. All right, what else do we have? All right, here are a couple more. I think this is the last one. Oh, those are going to be the answers. Okay, so go ahead, try these two problems, and then the answers will pop up. So again, hit pause, try these, and see if you get them right. Now, it's very important that you're pausing because I need you to get some of the feedback. So please hit pause, try them, and then check your answers. All right, so these should be your answers. We get negative 3 minus 7 is negative 10, and here we get 4 plus 10 is 14. Okay? All right, so go ahead and write down any questions you have for me, or anything that doesn't really make sense. I know that these ones are tricky. We're going to practice those in class on Friday, so by the time you see this, you should have already kind of practiced this. All right, here's 3 more just quickly. I need to make this second nature. This is 3. This is 1/2. This is 3. How did I know that? I just got to say 2 to what power is 8? 25 to what power is 5? 10 to what power is 3? I want you to get really quick at that. So hopefully this activity we're doing on Friday will be helpful. Okay. Thank you for watching this video.